In this video, we are going to learn what is a method. Method is a block of code that has some name and it runs only when it is called. Methods are used to perform some specific task. You can pass data to the method and the data is processed and written back. In some programming languages, methods are also called as functions. In Java, we call it as a method. Before looking at the syntax, let us try to understand why do you need a method or what is the use of a method. In our previous videos, we are writing the code inside the main method. But when you work as a programmer, your program may have 100 tasks or maybe 1000 or more lines of code. You just cannot stuff everything inside the main method. Your code becomes messy and inconsistent. Being a good programmer, your code should be simple and readable. Hence, you need to divide a task into a block of codes. Each method will have a task to do, and you can call that method in your program anytime whenever required, using its name. So how do you define a method? For this, Java has given us syntax. Syntax for method definition is, you need to define a return type followed with a method name. The method name can be any logical name that defines the task done by the method. Parenthesis. Inside the parenthesis, you may or you may not define the parameters. Method may accept data to be processed. The data to be processed is stored inside the variables known as parameters. Write the code. The processed data is written back using return keyword. The return type of the method and the type of the data should match. Example, here int is the return type, add is the method name, and it is accepting two parameters a and b. So this was about method definition. How do you call a method? If the method is non-static, you need to call it using an object. For example, name of the object dot name of the method and parenthesis. If the method is static, that means if the method has static keyword in the definition, you don't need to create an object. You may directly use class name dot method name. What is static and non-static? There is a separate video on this topic. You need to invoke a method using an object. What is an object? Object is an instance of a class. Class is a blueprint or template to create an object. Syntax to create an object is, you need to mention the class name followed with a reference name. This reference name can be any name you want to write. Equal to, new keyword allocates memory to the object, class name, parenthesis, and every Java statement ends with a semicolon. So let us try out a simple program to demonstrate how to define and call the method. Define a class using class keyword followed with a class name. Our class name is method demo. In this program, you have three methods, main method, and there are two more methods which are user defined, print text and increment. When you are using predefined method, you need to follow the exact signature. If you are writing your own method, you can decide the signature as per your requirement. Here I have defined the method. Method name is print text. This can be any logical name you want to write. Please follow the method naming conventions followed by the Java programming world. Whenever you write a method name in Java, the first letter of the first word should be in small case and the first letter of the second word should be in uppercase. So over here, print P is in small case and text T is in uppercase. Here, return type is void. Void is a keyword. Return type depends upon what type of data your method returns. If the method returns integer type of data, your return type should be int. If it is going to return a number with decimal point, your return type should be float or double. Here I am not going to return any data. I am just printing out something. When your method does not return anything, its return type is void. Void is a keyword that tells the compiler method is not returning any data. Hence I have defined void print text. Void is a return type and print text is the method name. We are just printing out the text in this method. Now the next method I have defined is increment. Again, this can be any logical name you want to write. Return type is int because the method is returning integer type of data. The method is also accepting one integer parameter and inside the curly brackets we write the code. Now let us see the execution of the program from the beginning. Entry point for any Java program is the main method. So as soon as you run the program, interpreter will check for the main method and start executing from there. We have defined non-static methods print text, and increment. To call the non-static method, we need an object. What is an object? An object is the instance of a class. You can create any number of similar objects from the class. So the syntax to create an object is class name. Our class name is method demo. Reference name is D. This can be any name you wish to write. Equal to new keyword, class name, that is method demo, and parenthesis. This is actually a constructor call. What is a constructor? We'll have a separate video on that. So to create an object of this class, we need to write method demo D equal to new method demo parenthesis. New keyword is used to create an object. Here, class is a data type. For example, when you defined int num, int is a data type and num is a variable name. In the same manner, method demo is a user-defined data type and D is the variable name. It refers to an object, hence it is called as reference name. Let us understand what happens behind the scene. Java interpreter reads this line, method demo D equal to new method demo. Memory for object D is reserved. Now there is a big difference between storing a variable and storing an object. In Java, memory is divided into different sections for different purposes. There is a stack memory area and there is a heap memory area. All the variables and its values are stored in the stack area. Even the object references are stored in the stack memory, but the actual object is created in the heap memory. There is a lot more to talk about stack and heap, but let us stick to our program and for time being try to understand that object references are created in stack memory area and actual objects are created in the heap memory area. Inside the stack memory, every method will have a space reserved for its local variables. So here inside the stack memory area, we have a section reserved for the main method and the variables belonging to main method will be allocated space inside this reserved section. Here the reference of an object, for example in our case D, is created inside the stack memory area and the actual object is created inside the heap area. This is the actual object. Reference D contains the address of the object created inside the heap. The actual object is stored on the heap memory area. So this reference variable D is just pointing towards the object created in the heap. The actual object is not stored in the stack. D is just having the address of the object. Objects are created dynamically at runtime. So here the object is created. Next statement is int num. Memory for variable num is reserved in the stack area, yet we have not assigned any value to variable num. Now this is a method call, d.printText. PrintText is a non-static method, hence we need to call it using an object. D is the object, hence we are writing d.printText. Now if you see the method signature of printText, method is not accepting any parameters. These parentheses are empty. Hence, while giving a method call, we are not passing any arguments to the method. As soon as the interpreter executes this statement, the control of the program will go to the method definition. So from here, the control of the program will go to the definition of printText and code inside the method will execute. So what code have we written? System.out.println. Println is the method that prints the data to the output screen. Here we are printing out the text, I am enjoying Java. This text will be printed to the console. When all the code inside the method is executed, the control of the program will return back to the point from where the method is called. So from here, the control of the program will go back to the method call and the next statement will execute. Here we have written variable num equal to d.increment. This is again a method call. We are calling out increment method. Increment method is a non-static method, hence we need to call it using an object. D is an object, d.increment, and we are passing out one integer argument, that is 9. If you look at the signature of increment method, method is accepting one integer parameter. Hence, we need to pass one integer argument inside the method call. So as soon as this statement is executed, the control of the program will go to the definition of increment method. So from here, the control goes to the increment method and the argument we have passed is captured by this variable a. Variable a is the local variable to increment method. So inside the stack, there will be section reserved for the variables belonging to the increment method. Hence, memory for variable a will be reserved over here. We are passing value 9. This value 9 will be stored inside variable a. Variable a is a primitive variable. It is not an object. Hence, value 9 will be stored here itself in the stack. Once the memory for the parameter is reserved, the code inside the method will execute. And what code are we writing? The first statement is a++. ++ is an increment operator. This is the shorthand for a equal to a plus 1. It increments the value by 1. So value of a is 9 plus 1 equal to 10. Hence the updated value of variable a is 10. Next is the return statement. Here return is the keyword which tells the interpreter that it has to return the value to the point from where the method is called. Value of a is 10. Hence value 10 is returned and control of the program is written back. So from here, control of the program is written back, value 10 is written back and stored inside variable num. So once the execution of the method is done, the memory occupied for the variables of increment method inside the stack memory area is released. The control goes back to the point from where the method call happened and the returned value 10 is stored inside variable num. So num equal to 10. The next statement executed is system.out.println and we are printing out value of variable num, that is 10. Hence 10 is printed to the output screen. Hence the output looks like this. Method print text will print the text I am enjoying Java. Method increment returns the incremented value, that is 10, and 10 is printed to the console. So this is how we define and invoke a method in Java. After the execution of main method, the memory reserved for its variables is released and the program terminates.